Hi everyone, so this is the last video in this lesson and it's all about how to use statistical models. So in the lesson, we talked about how to make scatter plots and how to determine if they're linear or quadratic exponential. We talked about the line of best fit, all of that. So now what we're going to do is put them to use by using them in word problems. And I didn't write the exact word problem down, but all four examples come from the same word problem, so I'll read it to you. It says, economists have found that the amount of corruption in a country is correlated to the productivity of that country. Productivity is measured by the gross domestic product, or the GDP, per capita. Corruption is measured on a scale of 0 to 100, with 0 being highly corrupt and 100 being least corrupt. This can be modeled by the equation y is equal to 424x minus 6,540, where x is the corruption score and y is the GDP per capita in dollars. So then it also gives you a table of all the information and a graph. Now the table, while it's important or good, it's not necessary for this because they gave us the graph. And the graph is what we're really going to be focused on. So I did draw a picture of the graph. So for the first question, it says, what does the slope represent? And obviously we can tell that the slope is positive. We can tell that it's linear because it's creating that straight line. But now we want to compare, or we want to figure out what it looks like or what it means within the word problem. And this is a little bit hard, but as you can see, as the corruption score goes up, or as the X values go up, so do the Y values, or the GDP. And so if I were going to write this in terms of X and Y, I could say the increase of X values also increases the Y values, but now I'm going to put it into words from the word problem. So I would say the increase in corruption score also creates an increase in GDP. And we don't have to be so specific about it. You don't have to tell me exactly what that is, or exactly how much it increases. But what I do want you to be able to say is that an increase in corruption score also increases GDP. Or we could have said it vice versa. We could have said the increase of GDP also increases the corruption score. It doesn't necessarily matter how you put it, because one, while they're correlated, that one is not caused by the other, so we don't have to put one first necessarily. But we just need to know that as one increases, the other also increases. Okay, the second example question says, what does the y-intercept represent? So the y-intercept, it doesn't show on the graph, but the y-intercept would be where that blue line crosses the y-axis. And it's going to cross, and at some point it's going to cross at a negative value. And that doesn't necessarily make too much sense within the word problem, but let's still continue on with it. When we talk about a y-intercept, we know that's where it crosses the y-axis. And the y-axis is where the x-axis is 0, or where the x values are 0. And so when we're talking about it within the word problem, we could say what the GDP is, because the GDP is on the y-axis. So what the GDP is when what's on the x-axis is 0. So in this case, it would be when the corruption score is 0. So once again, to figure out what the y-axis means, it's whatever the y-axis is when the x-axis is at 0. Okay, and then the next two examples are a little bit more mathy and a little bit less vocabulary. So the third example says, according to the model, what would the GDP per capita of a country be with a corruption score of 26? So they gave us this neat little equation to represent that line, and it was y is equal to 424x minus 6,540. And they told us that X represents the corruption score and Y represents the GDP. And so I want to know what the GDP is when the corruption score is 26, which means what I'm going to do is take this equation and replace the X with 26. So I'd get Y is equal to 424, but instead of saying X, I'm going to put 26 right there, minus 6,540. Then I can plug that into a calculator, and when I plug that into a calculator, I'm going to end up with 4,484. Because the GDP is in dollars, that would also be in dollars, so my answer is $4,484. Okay, and then example 4 is very similar. It says, according to the model, what would the GDP per capita of a country be with a corruption score of 88? So, same thing, we're going to use that same equation. Y is equal to 424 X minus 6,540, but now instead of replacing the X with a 26, our corruption score is 88, so I'm going to replace it with an 88. And then I'm going to plug that into a calculator. And, oh, and I wrote that weird. That's 424, not 428. When I plug that into a calculator, I am going to end up with 30,772, and that's in dollars, so it's $30,772. And this is how we interpret and use statistical models.